Hey guys, we're going to solve now worded problems using Pythagoras' theorem. We can use Pythagoras' theorem to solve real-life problems that may occur. Let's see one example. Here we have a gate that we're going to construct. Now the gate, as you can see, has 1200 millimeters in height and 2000 millimeters in width. And to construct this gate and to make it firm and stable and strong, we have to construct and create a diagonal to make sure that the angles of this gate, when we're opening and closing it, don't actually go awkward and are always 90 degrees. So what do? We actually construct what we call a brace. Now the brace in this case is a diagonal. What can you notice? You can notice that the diagonal, which is the brace, with the height and the length, make a right-angled triangle. So we use Pythagoras' theorem to find the length of the brace. So we can cut it and put it to size and construct this gate. So we are told that the height is 1200 millimeters and the length is 2000 millimeters. Find the length of the brace. Now, as I always say, look carefully and closely at the diagram. What do you notice? The brace is actually the hypotenuse. It's the hypotenuse for a right-angled triangle. One short side is 2000 millimeters, the other short side is 1200 millimeters. As you can see highlighted there, we have a right-angled triangle. The hypotenuse is the brace that we're going to create. So we're going to use Pythagoras' theorem to find the length of the hypotenuse, in this case the brace on this gate. Let's get started. First, we draw our diagram. Okay, now we have our diagram. We've created a right-angled triangle. Why? Because we know the brace makes a right-angled triangle with the length and the height of the gate. So now we have our length, our height, and our brace, which we're going to find. And here the brace is our hypotenuse. The length is 2000 and the height is 1200. So we can use Pythagoras to find the length of the brace here, and we know in this case the brace represents the hypotenuse. So let's get started with that. We know c squared equals a squared plus b squared. Well, c squared is the hypotenuse, a squared and b squared are the two short sides. Our hypotenuse is marked with an x. X squared equals 2000 squared plus 1200 squared. Okay, let's do it. We use our calculator and we're going to put the whole number sentence 2000 squared plus 1200 squared in our calculator, and then we're going to press equal. So grab your calculator. Let's do it. 2000 squared plus 1200 squared. Our answer $5,440,000. Now, what do? X squared equals 5,440,000. What are we going to do? We have to square root to get x because we only want x. So we square root our answer to the nearest millimeter. Our answer is 2,332 millimeters. So the length of our brace is 2,332 millimeters. You may ask, why are we using millimeters? Because builders and carpenters, when they are doing measurements to get exact, precise and accurate measurements, they use millimeters to get the right measurements when they are constructing or building something. Here we are building our gate. We need to make sure our brace fits in nicely. Our brace, we need to make sure it is 2,332 millimeters long to make this gate. Our next example. Our roof has a slant height of 13 meters. So the slant height of the roof is 13 meters. And the span is 24 meters. What is the vertical height of our roof? So looking at this diagram, we can see that the roof has a slant height of 13 on each side. The span down the bottom is a total of 24. The vertical height is what we need to know, which is the apex all the way down to the span, the center of our roof, marked with a H. What we can tell is that we need Pythagoras' theorem, and Pythagoras' theorem can only be used with right-angled triangles. So here we're going to cut the roof in half. That way we can have a right-angled triangle. H is going to be the missing side that we're looking for, and 13 is our slant height, which is opposite the right angle. What happens? It is our hypotenuse. And then the span is going to be cut in half because we cut the triangle in half. The span is normally 24. Cut it in half, divide it by 2, it's going to be 12. So now we have our diagram. This is half of our roof. The blue is our missing height. You can imagine this is one half and we had another half here. We cut it off. The span was in total of 24. We cut it in half and we have now 12. Our slant height is 13. So now we are finding the short side. We have our hypotenuse, it's our slant height, our right angle is there. And our short side down the bottom is half of our span. Our span was 24. When we halved the triangle, it became 12. Now we use Pythagoras' theorem. Notice we are finding the short side. What do? We remember our short side formula, a squared equals c squared minus b squared. We substitute. A is our missing height squared. C is always our hypotenuse. Where is it? 13. Minus, whenever we're finding the short side of a right angled triangle, we are always taking away. So minus b squared is 12 squared. You can put it in your calculator. 13 squared, take away 12 squared, 169. 13 squared is 169. Take away 12 squared, 144. H squared, 169, take away 144 is 25. We want H, we only need H, not H squared. What do? We square root. Always in Pythagoras, remember that. Then square root of 25. Our answer is 5. Therefore, our height, the height of our roof, the vertical height is 5 meters from the bottom all the way to the top, the apex of the roof. We use Pythagoras' theorem. We cut our roof in half. We constructed a right angle triangle. We labeled it with our hypotenuse, our short side, and we found our height. Hey guys, last example. We have a worded problem. Dad is installing a basketball ring on a wall. He needs to place the bottom foot of the ladder 1.5 meters from the wall, and he needs a ladder to reach 3 meters from the ground, leaning on the wall. What size ladder will he need to reach the height of 3 meters? So now we can see that we have no diagram. We have a worded problem, and in mathematics we're going to see that a lot, where we have a worded problem and we need to create a diagram from this worded problem. Now this needs very good comprehension skills, where you need to read the question carefully, you need to decode what the question is asking, what information is given, what information we may not need, because sometimes there's going to be information there that is not needed, and then construct a diagram, draw a diagram, and then solve our problem. If you solve it, you'll notice without the diagram, you couldn't actually do it. In fact, drawing the diagram is actually solving half your problem. So always get used to drawing a diagram. Here we have a diagram. We've constructed it from the information given to us. We know that Dad has to put a ladder leaning against the wall. Now the wall is vertical and the ladder has to be, the foot is going to be 1.5 meters from the wall. So for safety reasons, 1.5 meters, the foot of the ladder is going to hit the ground and lean towards the vertical wall 3 meters high. Now what size ladder will Dad need to actually lean against the wall? 1.5 meters from the wall is the foot of the ladder leaning towards the wall so he can climb up and install the basketball ring. Well, we have to use Pythagoras' theorem. We have a right-angled triangle. We have our vertical height. We have our ground. The foot of the ladder is there and the ladder is leaning against the wall. So now what is the length of the ladder that we need to lean against the wall 3 meters high so we can install this basketball ring? Let's get started. What are we finding out? Are we finding out a short side or a hypotenuse? Very important question. You always ask, am I finding out a hypotenuse or a short side? In this case, the ladder makes the hypotenuse for this right angle triangle. Let's get started. We know the formula, c squared equals a squared plus b squared. C squared is our hypotenuse and the other two short sides, 3 and 1.5. Three squared is 9 and 1.5 squared, 2.25. X squared is 11.25. Now of course you can put that in your calculator one hit and you're going to get 11.25. X squared is 11.25. What do we do now? We square root. Grab your calculator, square root 11.25. The ladder we needs to be at least 3.35 meters to 2 decimal places. Dad needs a ladder that is at least 3.35 meters to reach the height he needs to install this basketball ring. Again, very important. What do you notice? We are working out the hypotenuse. We simply use the hypotenuse formula. We square root it at the end. 3.35 meters is the size of the ladder that we need to install this basketball ring 3 meters high above the ground.